In this video, we're going to take a look at the idea of differentiability. So when are we able to take a derivative and when are we unable to take a derivative? So it turns out this is very closely related to the idea of continuity. So a function is not differentiable at points of discontinuity. Remember, it's continuous. Our intuition is it's continuous if you can draw that without lifting up your pen or pencil, if you can draw your curve. So it's discontinuous if there's a jump or a hole, if there's a vertical asymptote. But you also have a function is not differentiable. We can't take the derivative if we have a sharp corner, right? So it might be continuous there, but if there's a sharp corner, it might not have a derivative defined at that point. All right, so let's jot down a couple quick graphs of what this looks like. So we have a pictorial idea of when a function is not differentiable. So you might have something like this. So here at C, right here, we might have a jump in that graph. So the derivative of this function at C, dne, does not exist. It exists everywhere else. We can take our derivative everywhere else, but at C, we cannot take that derivative. That derivative does not exist. It was discontinuous at C. However, we could have something like a sharp point, right? A sharp corner. And so here at C, there's this sharp corner. And so that derivative there does not exist either. So even though it is continuous at C, the derivative does not exist. So the idea of a function being not differentiable, a function is not differentiable. At C if and only if the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, if that limit does not exist. Right? So if that limit does not exist, then our function is not differentiable at that point. Right? And so that's what we observed. So at those 2 points, that limit does not exist. That limit would exist at everywhere else for either of those two graphs that I drew. Right? So those are two separate graphs here. They are not the same graph, not a continuing graph. Right? But on both of those two separate graphs, at the point C, that limit would not exist. The function is not differentiable. But absolutely everywhere else, it was differentiable. So differentiability and continuity, very, very closely related. If a function is differentiable at x equals c, then the function is continuous. So if you know the derivative exists, then you know the function is continuous. However, the converse of this statement is not true. It is possible for a function to be continuous, but not differentiable at a point. Right? So the absolute value graph, there's a sharp corner, so it's not differentiable at 0, but it is continuous. We're able to draw that graph without lifting up our writing utensil. So if it's differentiable, it's continuous, but if it's continuous, it may or may not be differentiable. All right, we'll talk to you later.